if we look at a piece of string or a rope tied to a wall, then we can sort of flick one end to make a pulse travel down the string. So shaking the string at one end will cause the string at the other end to also shake in the same direction. And in this case, it's obvious that the string isn't moving back or forth, right? If we send a pulse down, then we don't have to get the entire string moving in that direction to carry the pulse. All we need is that little disturbance in the string to propagate through the string. So in this case, we're once again transferring energy without transferring matter. If we look at light, this is a type of wave that travels through physical space. It doesn't have water or string to travel through. If you could take hold of a little charged particle, for example an electron, at one end of the room and wiggle it around a lot, then you would create electromagnetic waves. This means that if you were to look at a similar charged particle on the opposite side of the room, it would behave in the same way as the particle that you originally jiggled. It's as if you were holding a string at one end of the room and shaking it up and down. It causes the other end of the string to also shake up and down. Except instead of ropes propagating through the wave, propagating through the string rather, they're propagating through empty space. So electromagnetic waves turn out to be the fastest type of wave. There is no wave that goes more quickly than the wave between two charged particles jiggling. So it turns out that, as we know, we can change some forms of energy into other forms of energy. And this is true for the energy carried by waves as well. So why is this important? Well, modern communications often use electrical energy, right? We have lots of electrical appliances, like mobile phones and satellite communication and instant messaging. And these all need to use electrical energy in order to carry messages. So if we can transform things to and from electrical energy, that means that we can use electrical waves to transmit messages. So we can, once it's being transmitted as electrical energy, we can transform that back to a form of energy that we can understand, like sound energy, if we're talking over a telephone. So let's take a look at the various energy transformations that happen when we talk on a mobile phone. We start off with sound energy when we're talking into the mobile phone, and the mobile phone will very quickly use its microphone to transform this into electrical energy. With me so far? Okay, now we take this electrical energy and we transform it into an electromagnetic wave. The type of electromagnetic wave is called a radio wave. And so once it's a radio wave, we can actually beam that to a mobile phone tower and that will send it up to a satellite in the same form. The satellite will decode part of this and then send it back down, still as a radio wave, into the destination mobile phone, right? And that'll transform it back into electrical energy once it's inside the phone. Of course, we can't hear electrical energy, so what we need is a speaker on the receiving phone in order to transform the electrical energy into, that's right, sound energy. And once it's back in the form of sound energy, the recipient can receive the message that the sender sent. So in this case, we have a number of different transformations of energy just to transmit a single message. But because one of the transformations turns it into radio waves, we can transmit that message extremely fast and extremely long distances.